Okay, SpongeBob challenge number 31. We're going to be simplifying um, rational polynomial expressions. And the first thing I want to demonstrate is that fractions that we're basically doing is simplifying fractions. Let's say we had 2 over 2. Well, 2 over 2 is equivalent of 1. Before we get to 1, we can simplify that to 1 over 1, such as, and 5 over 5 is equivalent to 1 over 1, which is also 1. Now, how do we get to these ones? If I was trying to simplify a 3 over 6, I can factor the 6 into a 3 times 2, and the 3 can be factored into 3 times 1. And then we have our 3 over 3, which is the equivalent of a 1, leaving behind the factors 1 over 2. Okay, once again, let's say we had a 10 over 15. Okay, this can be factored into a 2 times 5 and a 3 times 5. Again, 5 over 5, that's the equivalent of 1 over 1. And so you make that 1 times 2/3. So this up is 2/3. So the ideal is finding factors that will give you 1 to remove, and that simplifies the fraction. Okay. So here, let's take a look at 1. We have x is here and x squared is there. I'm going to factor this in such a way that it matches the least amount of x's there. So we have x here, and now x times x is up x squared. So we're matching x's. Here we have x minus 2 here, and there's no x minus 2's there, so we'll just write that over again. And here we have x plus 3 here, and x plus 3 there. Both of those. I'll fold this over just a little bit. Okay. So what we have here, this is equivalent to 1 here. This is equivalent to 1. And so what's left when you simplify is the x minus 2 and the x. And since there are no more factors here, you don't need the parentheses anymore. Take a look at number 2. Number 2, we have x to the third power and x to the second power. The most common would be x squared, so I'm going to get an x squared out of the x to the third. So this will be x squared times x. And then on the bottom, we have the x squared. Now we have a x minus 2. There are no x minus 2's in the denominator, so we'll just write that, x minus 2 to the third power. Next, we have the x plus 3, and there's an x plus 3 here. There's 2 of them here and 4 of them there, so I'm going to break this into factors that have 2. So this will be x plus 3 to the second power, and x plus 3 to the second power. All over this x plus 3 to the second power. Okay, and now simplify. This becomes a 1. This becomes a 1. And now what we have left is x, the x minus 2 to the third power, and the x plus 3 to the second power. Now this is all over 1, but 1 is understood, so this can be written as x minus 2 to the third power, x plus 3 to the second power. Next, we have 9x to the second power. We have x plus 3. That's to the fourth power. We have x minus 5. And that's the fourth power. And that's all over 6x squared, all over x minus 5 to the third power, x plus 5 to the fifth power. Okay. So let's walk through each one of these. We have a 9 and 6. They can be factored into a 3 times 3 and a 2 times 3. We have an x squared, those are matching, so we don't need to change those two. We have an x plus 3 here, and no x plus 3 is there, so we'll just write that down. Make sure I wrote that down correctly.
Oh, it's x plus 5.
Okay, sorry. It's x plus 5. So the x plus 5 here and the x plus 5 there. We'll have 4 of them here and 5 of them there. So I'm going to create this into x plus 5 to the 4th power. So x plus 5 to the 4th here. And this right here is written as x plus 5 to the 4th power times x plus 5. Okay. Basically to the 1st power. Okay. So that combination is that one right there. The next one is by x minus 5 to the 4th. And I have an x minus 5 here to the 3rd. So I want to break this into x minus 5 to the 3rd. So x minus 5 to the 3rd power times x minus 5 to the 4th power. Okay, all that is, sorry, 1st power. So all this matches x minus 5 to the 4th. And then I'll write this x minus 5 to the 3rd power. I really wanted to line these up so they're right on top of each other. But let's see, maybe I can do it. I'll switch this. I'll make this the 1st power and I'll make this the 3rd power. And so those two line up. Okay, let's simplify by giving all little ones. That's 1. This is also 1. This right here is 1. And this over here, these two right here, let's put it to 1. So what's left over is 3. The x minus 5 to the 1st power. 1 is understood. 2 here. And the x plus 5 to the 1st power. And the 1 is also understood.
Okay, let's take a look at number 4.
Okay. Now what we have here is a difference of 2 squares. And let's take a look at the difference of 2 squares. X squared minus 9, we take the square root of x squared and the square root of 9. We get x and 3. Then we write 2 binomials here with x plus 3 and x minus 3. So this simplifies into 2 binomials. So this will become x plus 3, x minus 3, and this remains x plus 4 here. Here, this is x plus 3. But this right here, the x squared minus 16, we make all this 16 here. This becomes a 4. So this will be plus 4 and minus 4. So this breaks into 2 binomials. And x plus 4. I'm going to write the x plus 4 over here on this side. And the x minus 4 over here. So I can get a little match here. Okay. So this right here is equivalent to 1. This is equivalent to 1. So what's left is x minus 3 all over an x minus 4. And that is finished. Be careful not to try to cancel the 2 x's here because these are not multiplying x's, but these have addition or subtraction. And you can't simplify when things are adding and subtracting, only when they're multiplying. Okay, here we have 4x squared minus 1. This is the difference of 2 squares. So we have 4x squared minus 1. So the 4x squared, when we take the square root of it, will be 2x. The square root of 1 will be 1. So we'll end up with a 2x. Bring that incorrectly, but 2x plus 1 and a 2x minus 1. So it's right here. 2x plus 1, 2x minus 1. And then we put the x plus 3 here. This is 2x plus 1. I'm going to continue to put this here underneath. And the x squared minus 9, we saw that x squared minus 9 becomes x plus 3x minus 3. So I'm going to put x minus 3 first and then x plus 3 second. So I want these to match or just to be right up under each other. Okay, this is equivalent to 1. These two are equivalent to 1. So what's left is our 2x minus 1 all over x minus 3. Okay, number 6. Number 6, we do have a difference of two squares right here, which is the 4x squared minus 1, which factors into the two binomials of 2x plus 1 and 2x minus 1. The x plus 3 is raised to the second power. We have an x plus, we're going to expand that into a x plus 3 and x plus 3. So that will simply expand it into x plus 3, x plus 3 here. 2x plus 1, I'll put it right here under this one. And the x squared minus 9, x squared minus 9 simplifies into a x squared becomes x, 9 becomes 3, square root of 9 becomes 3. So it gives us x plus 3 and x minus 3 when we simplify them. So this will become x, let's write it over here, x plus 3 and x minus 3. Okay. So I wrote the x plus 3 and x minus 3 a little further over here. All right, let's start simplifying. These two become 1. These two become 1. And that's about it. That's about as much as we can simplify. So we're left with our 2x minus 1 and an x plus 3. And in the denominator, we're left with a x minus 3. And notice we don't need the parentheses for the x minus 3, but we do need the parentheses for the 2x minus 1 and the x plus 3.